Good morning, Year 8. Thank you again for engaging with our online lessons. Please send me that message on showing my homework to show that you've accessed the lesson. I can mark you down the register and give out some reward points. Today's lesson is going to be self-marked again, so please make sure you have done some self-assessment for it before submitting it and show my homework, and I can give you some feedback on anything you might have made an error with. So today's lesson is going to look at percentage change and also repeated percentage changes. So our developing students are going to be able to calculate a percentage change in amounts. Secure students are going to be able to solve problems that involve compound interest or depreciation, and excelling students will be able to explain those methods that involve compound interest or depreciation. On to our starter then. I have 5 questions then where I'd like to work out these percentages of amounts with an increase or a decrease involved in them. And if you move on to question 4 and 5, we've got 2 percentage changes occurring there. So you'll have to work out the one first and then the second one. If you are happy with the multiplier methods from last lesson, then you might find these very quick to do, but have a go yourself first and I'll walk you through these multiplier methods afterwards. So if you'd like to pause the video until you've had a go at these, I can run through the answers. So answers as follows. So increasing 75 by 12%. Well, what we could have done is the long-winded way would have been to work out 12% of 75 and then add it on. If you think back to last lesson though with the percentage increases, we could have said that if you start off with 100%, when you increase it by 12%, you now have 112%, and we could use that as a multiplier. So we could do 112 over 100, or 1.12 times 75 to get straight to the answer. Likewise with question 2, if you're decreasing 64 by 16%, if you decrease something by 16%, you'd be left with 84% of it. So we could have done 0.84 times 64 to get straight to the answer. Number 3, increasing 549 by 4%. If you increase by 4%, you have 104%. So we could have done 1.04 times 549 and get straight to the answer. This really helps us out with questions 4 and 5. Because if I want to do question 4, rather than working out 5% to 400 and then adding it on, and then working out 6% of that and then adding it on, I can do it with the multipliers really quickly. Increasing by 5% gives us 105%, and then increasing by 6% gives us 106% of that. So we could have just done 400 times 1.05 for the 5% increase, and then times that by 1.06. for the 6% increase. That gets us straight to our answer, which is why the multiplier methods are much quicker here. Likewise, with question 5, if you decrease something by 10%, you're left with 90% of it, so 0.9 would be the multiplier there. And then to decrease that by a further 25%, that would leave you with 75% of the previous answer. So you times that answer by 0.75. So 80 times by 0.9 times by 0.75 gets us straight to this answer of 54 really quickly, rather than working out mentally those percentages and adding or removing them as necessary. For the first half of today's lesson, we're going to be looking at percentage change, and we're going to be calculating what percentage an amount has increased or decreased by. There's a little formula that's going to be well worth writing down to help you out with your notes on this. So percentage change is the change in the amounts divided by the original amount, and then that will give you a decimal answer, so we then need to times that by 100 to turn that back into percentages. So make sure you've got a copy of that in your notes, and we'll use this in a couple of examples now before you try some questions of your own. An example then. A computer accessories shop increased the price of one of its printers from £80 to £100. Find the percentage increase in price. So we can see here the original price was £80, that's what it started off as, and it's moved up to £100 as the new price. So our percentage change formula underneath is the change divided by the original amount and times by 100. We see here that this change is an increase, the price has got bigger. So our percentage increase is going to be the increase divided by the original amount times by 100. So what is that change, or what is the increase in the price? Well, from £80 to £100 is £20, which is our increase, and the original amount was our £80, so that's what the printer started off as, and we times that by 100. So we need 20 divided by 80 times by 100, that gives 25%. So our printer has increased by 25%. This is a calculation then to find out that percentage change. So now we're going to look at finding the percentage decrease in the cost of the car in this sale, and it's got 1 dp in brackets after there, so we only want our answer to 1 decimal place. So we can see that the original price of the car was £35,500, and in the sale it's gone down to £34,000. So percentage change formula again, we're after the change in the prices divided by the original amount and times by 100. So the change in the prices here from 35,500 down to £34,000 is a change of £1,500. Our original price here was the 35,500. So that's our original amount that we need to put as the denominator of the fraction, and then times our answer by 100. So we're after 1,500 divided by £35,500 times 100, and it gives us 4.2% to 1 decimal place. So watch out, you always have a look at the wording of the question. The original amount isn't always the largest number or the smallest number. You've got to say it's just what the starting amount was. I've got 3 of these for you to try then, to build your confidence before we move on to the main written activity for this half of the lesson. So work out the percentage change that's occurred in each of these 3 cases, and we'll run through the answers as soon as you've unpaused the video. So answers to the first one, we should have a 10% increase. We've got a £10 change in the price, and then the original price was 100. So 10 divided by 100 and times by 100 gets us that 10% increase. For the second one then, we should have a 20% increase because the price has been raised by £50 and the original was 250. So 50 over 250 times by 100 gets us that increase. And then the final one, we should have a 16.7% increase. You might have 16.6 recurring on this, but make sure we just round it to 1 decimal place there, as we should have had a £12.50 increase on those numbers, and then the original was 75, so 12.5 over 75 times by 100. And of course in each of these cases we notice the new amount is larger than the original amount, so it all increases here. Watch out for the cases where you might have a decrease in this. So decide on how confident you feel with this half of the lesson and write red, amber or green in your book, and then we're going to go and complete the corresponding activity for activity 1 that's attached to show my homework. Remember, you only need to complete either the red or amber or the green. They're all the same questions, it's just that varying levels of support. I think in this activity the red one's actually first, which is usually the green ones on the previous activities, so do be careful on that and which one you're choosing. Remember, red has lots and lots of support, amber has a little bit of a hint on what to do, and then green is no support, so if you're feeling really confident with those activities. So if you'd like to pause the video until we've had a go at activity 1, and then we can move on with the lesson. So answers are going to come up now. If you'd mark your own work, please. Remember, anything that you're sending in should be self-marked at the moment, so that I can give those pointers only on anything that you've made a mistake with. So once you're self-marked, if you'd like to unpause the video, and we can carry on with the second part of today's lesson. Moving on to the second half of today's lesson, then we're going to look at repeated percentage change, and this can be called compound interest or depreciation, dependent on whether we are increasing our amounts or decreasing them. Now there's a couple of ways of working out repeated percentage change. One of the ways that you must be aware of is called simple interest, and this isn't really a real life way of doing things, but it might be asked in an exam style question. So simple interest, as the name suggests, would be a very easy way of working out percentages. For example, if you put money in a bank actually pays you a small amount back as a thank you for leaving the money in that bank. So if you put £100 in a bank, they might give you 2% interest each year. And simple interest would say, well, 2% of that £100 is £2. So we'll just pay this customer £2 every year for however long that they leave the money in the bank account. That actually isn't the realistic way of doing it. There'd be a very simple way of doing it, so it's obviously given the name simple interest. But actually what the banks do is they'll give you that £2 for the first year, and then when they go to calculate for the second year, they'll say, well, hang on, this person's now got £102 in the bank account, so we'll find 2% of that and pay the interest on that. So it's only a small amount extra, but it does actually soon add up when you do these repeated percentages. And if you recalculate every year and give a percentage based on the new amount, then this is called our compound interest or depreciation. The formula for it has been on the screen while I've been talking over percentages. It'd be really worth you writing this down in your notes. So when you're working out this compound interest, the new amount is the original amount multiplied by the percentage change to the power of n. Now, obviously we don't know what n is yet, so I'm going to give a couple of little provisos for this formula that may well be worth annotating your notes with as well. Our percentage change must be given as a multiplier, which we've talked about in our previous lesson as well. And then n will be the number of years or the number of periods that this percentage change is given over. So it's very, very often in real life situations that this percentage is worked out annually or by year. And another way you might see this written is for the number of years. You might see that percentages are given PA or per annum. Remember, annual means per year, so per annum means the yearly percentage rate. Of course, this formula still works as well if your interest was calculated every month, then n would just be the number of months, so it's the period that the interest is calculated over. The one to really watch out for is that our percentage has to be as this multiplier. This means that if your bank was paying you 7% interest, then you'd think, well, if your bank account is going to increase by 7%, you'd then end up with 107% of the original amount. So actually your percentage multiplier there would be 107 over 100 or 1.07. So you can't just put in the straight percentage in this box, but you must put the multiplier in for it, which we'll talk through in our examples coming up. So example 1. If you put £500 in a bank for 4 years and were paid 3% interest per year, how much would you have? So what we could have done is we could do this really long-winded way, and we could have said, well, what's 3% of £500? Okay, that's £15, and we could add that on. So at the end of the first year, you'd have £515. We could then work out 3% of that and add that on, and then 3% of our next answer and add that on, and then finally for the 4th year, 3% of that and add that on. It's an incredibly long-winded process, so we really want to be using our formula here. So remember, the formula is our new amount equals the original amount times by the percentage, which has to be a multiplier, to the power of n. So our original amount here, we've got given to us as our £500, because this is the amount that we first put in the bank, so that's fine. Our percentage then is going to be the interest rate that we're given, so this is our 3%. Now, interest in this case, if you put money in a bank, is going to be an increase. So what we're after here is what is the multiplier for a 3% increase. We've got to remember there that if you always class your original amount as 100%, if you increase something by 3%, you'd end up with 103%. Excuse my mouse handwriting there. And then the multiplier for that is that 100th of it, 103 over 100. So our multiplier for our percentage here is a 1.03. Is our multiplier for our percentage increase. And the final bit is a power. So we needed the power of the number of years that this is going to go on by. And then we can see here that it's happening for 4 years. So here are the numbers in our calculation then. Our original amount is 500. Our multiplier for our percentage, this is probably the quirkiest part of these questions, is the 1.03. And then our power of n that we raise it to is 4. So obviously going to be calculator used to do that power. So 500 times 1.03 to the power of 4 will get us straight to our answer for the end of the 4th year, which will be £562.75. So that's not too bad. You've earned £62.75 on that account for doing nothing to it, just leaving it in the bank for 4 years. And obviously you can imagine how that would account if you had maybe £5,000 in the bank. You'd have made a lot more. And those people that have been earning loads and loads in the country and have millions of pounds in the account would obviously earn loads and loads of money for actually doing nothing with it. So another example we're going to move on to. Here we've got what if you put £100 in the bank for 24 years and were paid 4% interest per year? How much would we have at the end? So again, our formula, the new amount is the original amount times by the percentage to the power of n. So our original amount again, how much did we put in the bank account to start off with? is £100. Where's our percentage? Well, we can see that the percentage interest being paid here is 4% interest. And then again, we need to just have a think about what that would look like when we start to think of the multiplier. So if you consider 100% as our original amount, if you increase it by 4%, you then have 104%. And then the multiplier for that would be 1/100th of it, 104 over 100. So our percentage multiplier is 1.04 in this case. And then we want it to the power of n, so to the power of the amount of years that have passed in this case. So n here is going to be 24 years. We should be aware that powers increase very, very quickly, so this might have a big change on our amount here with 24 years. So our final calculation, 100 times by 1.04 to the power of 24. Final answer to this, then it should be £256.33. So we'd end up with about 2.5 times our original amount for this, for just leaving it in the bank for that long. If you imagine if you had £1 million in the bank, we'd have almost 2.5 or just over £2.5 million left there for not doing anything in the bank. So incredibly powerful compound interest. Now, the reverse of compound interest is depreciation, and this is where something decreases. So if you think about the value of electronic goods like computers, they decrease year on year as new and improved computing technology comes out, or the computing technology that you've got wears out. And then the same with cars, we've got the example here. So a car loses its value each year as it gets older, there's more efficient fuel cars coming out, or there's just general wear and tear on the vehicle. So in this case, this is called depreciation, where the percentage decreases each time. So you can see the D at the start of it for decreasing. So a car loses 12% of its value each year. What is it worth after 7 years if it cost £12,000 when new? So it's exactly the same formula. We've just got to be aware when we look at our percentages that we are decreasing this time. So let's have a look for our original amount. Well, that's going to be our £12,000 that the car cost originally. What's our percentage then that we're going to have for our depreciation? So the percentage here is our 12%. We've got to be really careful with this though, because remember we're decreasing here, it's losing this value. So a car loses 12%. If the original was 100% and you lose 12%, you're left with 88% of the value left. So that's going to help us to get our multiplier. Remember, the multiplier is always 1/100th of that straight percentage though. So if you've got 88% here divided by 100, our multiplier here is going to be 0.88 for that multiplier. And it's really, really important that you catch in your question by having a look at the wording, whether it's an increase and you'll have over 100%, so a 1 point something for your multiplier, or whether it's a decrease and you'll have less than 100%, so 0 point something as your multiplier. And the easier part to spot here is the amount of years over which this has occurred, and we can see here that's 7 years. So our final calculation here is going to be our £12,000 times by 0.88 to the power of 7, and that's going to give us £4,904.11. And again, if you get a longer decimal there, remember that we're dealing in money, so it only makes sense to round it appropriately to 2 decimal places. So watch out with these compound interest or depreciation questions, because it can be tricky to decide on your multiplier. Have a look whether you're increasing in value with the compound interest, or whether it's decreasing in value year on year, which is our depreciation, because that'll obviously affect this multiplier as we've talked through. So make a decision again on how you feel with your confidence for this activity 2. And as usual, we're going to write the red, amber or green and make the decision for which activity to complete. And then again, if you'd like to pause the video until you've had a go at that, and then we can run through the answers. So answers coming up. So if you can self-mark your answers, please, before anything gets sent in to me, and then I can give you a hand with any of those questions that you might have struggled with. So thank you for engaging with today's online lesson again. Please send me that message on Show My Homework if you haven't already, so I can mark you down the register and give reward points out. And today's lesson, as we said, should have been self-marked. So if you are sending in work on Show My Homework, make sure you have ticked or crossed it, and I can give you some more effective feedback from it. And if you needed any help, hopefully be using red@theroyal.school for that. Thank you very much, and I'll speak to you later in the week.